Welcome back to the deep dive. Today, we are strapping in for a journey into one of the most technologically advanced and high-stakes sectors of the global economy. We're talking about the transport and use of liquefied natural gas, or LNG, on ships.
It's an environment that's really defined by extremes. I mean, think about it. You're moving these vast quantities of natural gas, which is simultaneously cryogenic. It's chilled to minus 162 degrees Celsius, and it's highly flammable.
So if something goes wrong,
You're dealing with a massive fire potential and at the same time structural failure from the extreme cold. It's a dual hazard.
and that's the tension we're diving into.
Yeah.
Our mission today is to cut through some of that, bureaucratic fog
Right.
and really unpack the critical human element. How do global regulators make sure that every single person on board, from a deckhand all the way up to the captain, is absolutely competent to manage these risks?
Exactly. This isn't just about ticking boxes.
Oh.
The sources we looked at make it crystal clear. Competence is the only real defense against catastrophe here. Certification is the bedrock. We're not talking about simple ship handling. This is precision engineering, advanced cryogenics, complex chemical processes, all happening at once.
The cost of human error is just immediate and severe.
Absolutely. For safety, for the environment, and for global trade.
So let's start at the top then. When we talk about global maritime law, we always seem to start with one organization.
The International Maritime Organization, or IMO, they set the entire framework.
And what's the foundational document, the one that dictates who's even allowed to work on a ship in the first place?
That would be the STCW Convention. It stands for Standards of Training, Certification, and Watchkeeping for Seafarers.
Right.
And the STCW is so critical because it mandates a global minimum standard. It makes sure that a qualified officer from, say, Greece is recognized as competent on a ship registered in Panama.
That idea of a minimum standard is just essential for an industry this global, and the STCW breaks down competence into different levels, doesn't it?
It does, from support staff to operational crew, all the way to management. It dictates the education, the mandatory sea time, the practical skills you have to demonstrate to earn your certificate of competency.
But that's for general skills. When you introduce something as complex as LNG, the rules have to get a lot more specific.
They have to, and that's where the specialization comes in. LNG is what's called a low flash point fuel, and there's an entire rule book just for that.
The IGF Code.
Yes, the International Code of Safety for Ships, using gases or other low flash point fuels. We just call it the IGF Code. And it's mandatory under the Main Safety Convention, SOLAS. It was a necessary addition because, the standard rules just didn't cover the unique risks.
And crucially for our deep dive, the IGF Code is what defines the specific training for everyone working near these fuel systems. So it's baked right into the STCW structure. They're totally interdependent.
Yeah, and what I find fascinating is the enforcement layer. It's this great example of distributed global governance. You have the flag state, the country where the ship is registered, and they issue the actual certificate of competency. But then you have port state control.
The inspectors, the people who can show up unannounced.
Exactly. When an LNG ship arrives in, say, Rotterdam or Singapore, PSC officers can board it. They check everything, the ship, the crew's documents, all of it. They're looking for compliance. They function as a global quality control.
And they have teeth.
They have serious teeth. If they find the crew's training is lacking, they can detain that ship. A multi-million-dollar operation just stopped dead in its tracks. That provides huge leverage for keeping standards high.
Okay, before we get into the specialized gas training, let's just quickly run through the basics. The documents everyone needs, no matter their rank.
Right, so beyond the obvious passport, every seafarer needs a seaman's book or discharge book. It's basically the official log of their entire career at sea, where they've worked, for how long, their rank. It's how you prove your sea service.
And of course, you have to be physically ready for the job.
Absolutely. A valid medical certificate is mandatory, proving you're fit for duty. And here's a practical hurdle a lot of officers face. If your certificate of competency is from one country, but the ship is flagged in another,
You need an extra step.
you need what's called a flag state endorsement. It officially validates your certificate for that specific ship. Without it, you can't serve.
Okay, let's move to the universal safety training. Everyone needs these basic modules, but on an LNG ship, they must feel a lot more immediate.
For sure. Everyone has to complete the 4 mandatory basic safety training modules. That's personal survival techniques, first aid, personal safety, and crucially, fire prevention and firefighting.
And that fire prevention piece is so relevant here. A fire on a regular container ship is one thing. A fire involving LNG is a whole different category of disaster.
A completely different category. That's why officers and key safety personnel have to go beyond basic firefighting. They need advanced firefighting.
So they're not just learning how to use an extinguisher.
No. They're training to lead a coordinated strategic response to a major fire. They have to understand systems unique to LNG, like high expansion foam or special dry chemical systems designed for cryogenic fuel fires.
So the stakes are so high that you mandate leadership level response capability.
Exactly. You're not just training someone to react, you are training them to command. And it's the same idea with survival craft and medical training. At least one senior person has to have a full medical pair certificate to stabilize someone until you can get help from shore.
All right, now we're getting into the specialized territory, the stuff dictated by the IGF Code. Let's break down the 2 tiers of training for handling these fuels. Let's start with basic.
Basic training is for everyone on the ship. Think of it as getting your foundational driver's license. It's all about awareness. You learn the unique properties of LNG, that it's odorless, invisible when it leaks, how the extreme cold can make steel brittle.
So that training ensures the galley staff, for example, knows not to just walk into an area where there might be a gas leak. But the real expertise is in the next level, advanced training.
All right, the advanced training is the professional certification. This is mandatory for the entire management team. The master, chief mate, chief engineer, second engineer, and anyone else who is immediately responsible for the fuel systems.
And what's covered at that advanced level? What makes it different?
This is where you dive deep into the engineering and the process management. You're studying the detailed design of the fuel systems, the control logic, how to do risk assessments for bunkering, and what to do when things fail. It's about analyzing a complex system failure, not just following a simple checklist.
That distinction between basic awareness and advanced management is so important. Now, there's a crucial fork in the road we need to talk about. The difference between a ship using LNG as fuel, which falls under the IGF code, and a ship carrying LNG as cargo.
Oh, that's a massive difference. A huge difference in responsibility. If you're just running the ship's engines on gas, you're worried about the fuel system. If you are operating a full-on LNG carrier, you are managing millions of cubic meters of cryogenic cargo.
So the training has to be even more specialized.
Much more. Personnel on those carriers need extensive additional training. It covers the deep mechanics of the cargo containment systems, the different designs like Moss tanks or membrane tanks.
And managing the cargo itself.
Exactly. How to manage the natural evaporation, which is called boil-off gas. This means operating sophisticated reliquefaction plants that recool the gas. It covers gas detection, tank inerting. This crew is basically running a floating chemical processing plant.
Let's zoom in on the people leading these operations, starting with the master. What kind of academic background do you need to command a vessel this complex?
Well, the minimum expectation is a bachelor's degree in nautical science. But for these top-tier LNG ships, the sources we saw suggest that advanced degrees, even a master's, are becoming a real advantage.
Because they're not just sailing the ship.
Not at all. They are making strategic decisions under extreme pressure. So beyond their main master's certificate, their specialized training focuses heavily on cargo operations leadership. But maybe the most crucial thing is crew resource management, or CRM. On a conventional ship, CRM is important. On an LNG carrier, it's everything. The master has to lead this team through incredibly precise, high-risk procedures.
Leadership failure becomes operational failure instantly.
Now let's talk about the chief engineer. This person is responsible for the heart of the ship, the propulsion system. And it's incredibly complicated on a gas-powered vessel.
So what's their background?
Minimum is a bachelor's in marine engineering. But with modern dual-fuel engines like the MEGI or DFDE types, a master's degree in something like cryogenic engineering is a huge asset. They are running systems that handle gas at extreme pressures and temperatures.
Give us a feel for that complexity. What does dual fuel actually mean for their training?
It means they have to be experts in 2 completely different maintenance regimes at the same time. They manage the LNG fuel gas supply systems, pumps, vaporizers, all operating cryogenically. And they have to understand the intricate combustion of the dual fuel engines themselves. Troubleshooting a compressor failure with cryogenic fluids is a skill set way beyond what a conventional engineer has.
Sounds like a constant training cycle, and we can't forget the technical specialists like the electrotechnical officers, the ETOs.
ETOs are absolutely the backbone of modern shipping. Their training is intense, focusing on instrumentation and control systems. On an LNG ship, they are the experts on the gas detection matrix, the emergency shutdown protocols, the alarm systems, And because these systems are all interconnected, their training now has to include rigorous cybersecurity for the operational technology, the OT systems.
So the ETO is half electrician, half system security expert. And finally, the ratings, the general crew. They aren't managing the controls, but their role is vital.
Absolutely. They have their basic certifications and the LNG familiarization courses. Their training is about identifying hazards, knowing the visual cues of a leak, how to use the specialized PPE, the cold weather gear, and knowing their exact role in an emergency. They are the eyes and hands on deck.
So we've established that getting certified is just the starting line. Competence has to be continuously maintained. And simulators are now essential to that.
High-fidelity simulators are the only way to train for disaster without causing one. They are indispensable. And these aren't video games. They replicate the actual control logic and dynamic response of the ship's systems.
What kind of scenarios do they run? Give us an example that really shows why they're so necessary.
Okay, they'll practice a critical, time-sensitive operation. For instance, simulating a sudden catastrophic pressure drop during bunkering. The officers and ETOs have to work together under stress to find the root cause, hit the emergency shutdowns, and communicate clearly, all within minutes. It builds decision-making skills, teamwork, and that crucial muscle memory for a real crisis.
Right, so the simulator builds the theory, but every ship is a little different. Which brings us to on-the-job training, or OJT.
OJT is paramount. You might be certified on paper, but you need supervised, structured time to get familiar with that specific vessel's layout, its unique systems, its emergency stations. Good companies have detailed checklists in their safety management system to make sure OJT is standardized and documented.
And to keep those skills sharp, drills must be constant.
Constant. Fire drills, gas leak alarms, collision scenarios. And they have to be followed by detailed debriefings to see what could be done better. On top of that, nearly every certificate has to be renewed, usually every 5 years. That means refresher courses and proof of sea service. It forces you back into a training environment.
And with technology changing so fast, that 5-year window must feel like a race to keep up.
It is a constant race. The idea of continuous professional development, or CPD, is non-negotiable. If you were trained on one engine 5 years ago, you need CPD today to understand the new integrated bridge controls or updated fuel protocols. The standards demand it.
We've laid out this rigorous global framework. But creating a standard is one thing. Enforcing uniform quality across thousands of training centers worldwide is another. What are the big challenges to standardization?
Well, the primary hurdle is just the variation in quality. While the IMO sets the minimum bar, the resources and expertise at different flag states and training centers can differ wildly. This can create a gap where some places just teach to the test instead of ensuring a deep, practical understanding. Port state control helps, but ensuring training quality is a huge global challenge.
And the technology challenge, it's not just about learning new systems, it's about the seafarer's job fundamentally changing.
Absolutely. The trend towards smart shipping, automation, AI, it means the job is shifting from manual work to supervision and data interpretation. Traditional maritime curricula, which focus on basic seamanship, they struggle to incorporate the digital literacy and data analysis skills that are needed now.
So we've covered the bureaucracy, the training, the tech. Let's tie it all together. What is the ultimate impact of all this on operational risk?
The impact is profound. By standardizing and verifying competence, you massively reduce the risk of human error, which is still the leading cause of maritime incidents. And when an emergency does happen, the training ensures a swift, coordinated, pre-rehearsed response. That's what stops a small leak from becoming a catastrophic explosion.
And beyond the technical risk, this culture of mandatory competence must change the whole atmosphere on board.
It creates a strong, proactive safety culture. When people know their job, they're confident. They're empowered to challenge unsafe practices, and they're more likely to report near misses because they understand the risk. And trained crews are vital for environmental compliance, preventing methane leaks and managing emission systems correctly.
It's a powerful conclusion. The safety of these incredibly complex, high-value assets is entirely dependent on this multi-layered, continuously verified human framework.
It just confirms that in the high-tech, automated world of LNG shipping, the most important piece of technology is still the certified human being.
So we've looked at the current requirements, but let's look forward. As the next generation of LNG vessels integrates even more automation, AI, and predictive systems, the role of the officer is going to change dramatically. The computer will analyze the data, the human will need to interpret the anomaly.
And that's the provocative thought to leave you with. What specific training do we need to develop now for those future seafarers? We have to shift the focus toward data interpretation, advanced cybersecurity for these OT systems, and maybe most importantly, enhanced human-machine interface management, teaching people how to trust, but also verify, and ultimately take command from a complex automated system when the unexpected